Okay, let's not wait any longer. So good morning, good afternoon. I am Patricia, and I am delighted to present today's webinar. And today we will explain how to improve automotive quality inspections thanks to machine vision and tunnel technology. So let's take a look to the agenda. Please, Mike, go to the next slide. First, we will give a quick overview of the quality concerns and the causes. We will present the machine vision technology and its application in the tunnel concept. Then we will follow with a small demo to show you the architecture of this tunnel. We will connect with Paula. Then we will have an explanation together with Michael Cooper of how this technology works for different types of inspection like metrology, defect detection, component validation, among other. And then we will have the jewel of the event. We will have a demonstration of how this tunnel works. We will analyze a car, we will inspect a car, and then we will show the results. We will have it with our developer manager, Daniel. Then finally, we will show other types of analysis and dashboards we can obtain, and we will introduce who Eines is. And at the very end, we will have an open Q&A session. So please write in the chat your question, and at the end of the session, we will answer them. Okay, so let's talk about our participants. So as I have said, Michael, our business developer manager, vision expert, will be the main speaker of today's. Then Daniela and Paula, we will perform these demonstrations with the tunnel that we have in our headquarters, in our showroom. And then myself, I will be the event moderator, okay? So... Okay, so now before Michael starts explaining these quality concerns, I want to ask you a poll question. Okay, so let me share with you. Okay, so what is a poll question? This poll question is like a survey. It's totally anonymous, and we will not show your names. We will simply show the results in percentages to make it a more interactive event. Okay, so please, we would like to know what is the most important quality concern for you. So is the misalignment of the parts, the paint defects, the surface defects, the absence or wrong exterior components, or having no data? So thank you for all your answers. And let's wait a couple of seconds to see all the votes. And Mike will comment them.
Oh, thank you, Paula. Thank you, Patrice. I really appreciate you getting this thing started. It looks like we even got a couple more that are late to answer. But as we can see that, the misaligned parts, which is a huge concern, especially in the newer vehicle builds, as we look at the aesthetics of it, along with the paint defects and surface defects are top three, definitely are ones that our system can inspect, and we'll cover those items.
Exactly, Mike.
Okay, well,
so having said that, you can continue with the presentation.
Yeah, I appreciate you giving those poll questions, and hopefully everybody on the line is excited to get into the webinar and learn some of the quality concerns in the automotive production field. Just a quick snapshot from the National Highway and Safety Association, real briefly, right? This was our 2022 production, but it was like 81 million, but 25 million of them had affected recalls. So we're nearly better than a third of all the vehicles produced had some sort of recall. With that being in mind, on average, there's like 399 recalls annually. That's like amortizing it out to almost one a day. So in the last 3 days, there's been a plethora of them, right? As the days have gone on, I saw that there was 550,000 vehicles that were recalled, 143,000 passenger cars, and then EVs happened to be recalled for trim pieces falling off. So that's just kind of the update to the last 3 days in current news. But what you'll see here is where some of the most important challenges and similar to the poll questions as to what makes up many of the recalls and quality issues that are occurring within the automotive builds. And, better than, in the 20% range, we're talking some sort of paint or fit or component and surface all lead the pack. And we've got some other, warranty claims that end up occurring. So one of the things that we wanted to make sure that all of our attendees here understand is that Eines Vision Systems provides a more objective type of solution. Most of the inspection that's being done on the vehicles as they're coming down the line is visual inspection, and we're connecting with maybe 80% of the defects when you're doing visual inspection, and several challenges come with that with regards to workers having to be there, fatigue, and the cost that is incorporated into this. One of the nice things with the fixed camera system that we provide is that we're able to inspect very objectively through all three shifts with the same cameras over and over and over again. And what we've been able to do is produce a system that allows us not only to be objective, but also to incorporate some of the latest machine vision AI, so that artificial intelligence is developed in the models that we provide our customers. And it's an ever improving model for defect detection and or measurement. How our system works primarily is that we look at various different types of defects. Okay, so our cameras can be aligned and set to collect the data of what a high resolution camera can do, and determine either mismeasurements or errors on the surface of the vehicle. And through our algorithms, we're able to improve and look at the different simulated errors and produce models. And when we're producing these models, we're able to do comparisons of the models to any of the errors that we're finding as defects on the car. Most importantly, once we've determined that there is a non-conformance in the vehicle, we're able to pinpoint where on the vehicle that non-conformance applies. And you'll notice here we've got it dotted with red dots. So maybe it's a situation where it's a gas tank cover wasn't installed, or it's the wrong color. We've got maybe an issue with regards to fit and finish on the rear lamp as it's fit to the quarter panel. It might be on the lift gate. So these are types of feedbacks that we're able to provide those that are performing any corrective actions on the vehicles. So some of the systems that we're going to explain today primarily are our tunnel systems, and we're going to be able to move forward with that. Went a little too far. I wanted to show and share a screen real briefly with regards to a video that just to show how simple our systems are and how simple our tunnels are for application, right? So while we don't work quite at this speed, we do provide a very good installation of our tunnel, and we're able to do this in a very fast fashion. One of the things to keep in mind is we're very modular, and so all of our systems that are shipped to any of the OEMs are a very modular system, and we're able to easily configure them for those vehicles and easy to maintain. So with that being said, I'm going to go to our next slide, talk real briefly about our quality control process. Now, as we go through the process of looking at our technology. If you have any questions, please put them in the chat. Then we'll be able to address those at the end. We've got a Q&A session, and we can go from there. I think we got somebody who has raised their hand. Is this something that we can talk about when we get to the Q&A session?
Yeah, so it's better that write your thoughts on the chat, and I will answer them at the end of the event.
Yeah.
Please, Mike.
Just for the sake of time, I think we want to make sure that when we do our demo, maybe some of your answers or questions will be answered.
Exactly.
And also, as we get through deeper into the technology, maybe some of those questions will be answered. And by the time we get to the Q&A, which we'll leave ample time for, I want to make sure that we're able to address the questions that are in the chat. So with that being said, as long as everybody can hear me and it's not a technical thing in terms of my audio, what I would like to do is just quickly cover this quality control process and the magic behind why we're able to install our systems in such a very quick and robust way is that we take the time up front to know the vehicle and to develop a 3D simulation for that vehicle. That helps jumpstart the entire process of from the CAD drawing information installed into our software that we've been able to develop. And then what we're able to do is build out the system very quickly. So we're able to then display any of the repair or non-conformances. That data is then collected and can communicate to an OEM's MES system, or it can stay local on our server for a certain period of time. And that period of time can be, anywhere between 1 week to 1 year, depending upon the desire of the OEM as to how you want to collect that data. Next is how do you want the data displayed? And we're able to place it into either customized screens or pushed to a OEM's MES system, and they're able to take that compatible data and put it into their screens. So all of their folks on their intranet can see it, but just keep in mind, it's 100% inline inspection on each and every vehicle. So that can create, a significant amount of data, but it can also create a significant amount of solutions for everybody to make better vehicles. So with that being said, I'm going to introduce to you Paula. Paula is going to do a quick tech demo of our system as she's real world on the factory floor. So Paula, go ahead and take it away.
Hello, I'm Paula, and I'm in charge of showing you our showroom with some of our products and also the tunnel that we're gonna see later for our demo. So come with me. As you can see here, this is a solution for wheel and tires. This is called the dot reader. This verifies that the DOM and the dot is correct. We also have what we call the rim surface inspector. And what does this solution? This solution is for verifying the quality of the rim. Everything is okay? Is there any problem with the rim? Let's go to the cabinets. We have more type of cabinets, but in this case, we have here the end-of-line cabinets. You put here the pieces, and this solution inspects if everything is correct, as every solution that we have here, because we are a company of quality control. We have here our operator guidance. This is a solution that has two parts. First of all, what we internally call the pick and place, where it says to you if everything is correct or if it's anything that it must not be here. And well, right now it's switched off, but here it shows a screen where it shows if the operator has a good position, maybe he has the PPEs put it, or well, maybe if something dangerous is coming to it. Finally, we have our press shop solution. But now let's go and see the important part. Our all-in-one tunnel, the tunnel that you have came to see. We are gonna start from the internal part to the external part. So if we go inside of our tunnel, let's start from the basics. This is a tunnel combined of 3 different tunnels. First of all, we have our surface damage inspector. With the zebra light, as you can see here, white and black, we can inspect if there's any problems such as scratches and dents. If we move some steps further, we have our metrology part. This part detects if there's any error of measurements. And also we have our component check part. This analyzes if every component is in place or if there's something that is not where it must be, and if all the components are correct. Just to inform you, in terms of speed, more or less we can analyze 1.5 cars per minute, and more or less it's 2.7 meters of height, 2.6 of weight, and 5 meters of long. This makes that fits in almost any place, so we can have a lot of space in our plant. This is the internal part, but now let's move to the external. In the left, we have our electrical cabinet. Here we have our inputs and outputs modules, as also other electrical components. And we have here our IT cabinet. Here is where all the data is processed. But let's now move to the other part of the tunnel. Here, in my left, we have the screens. Here in the screens is where then, after we're gonna see all the reports, where how all the reports are represented. Our developer manager will show you how the car moves, and then the reports are represented here. We have the screens. We also have our EH2, where after they are gonna show you how they work. And also we have our tablet, where we can show how it's more efficient to work with the tablet, because you can go to the place and just check it without coming to the screens. So I hope you liked how I explained the structure and the showroom. Now let's move with our vision expert, that they are going to explain you a briefly explanation of our systems, and then don't go yet, because then we're going to see our live demo. So bye-bye, and thank you very much.
And thank you very much, Paul. I really appreciate the walkthrough, and I think that helps give a very good overview of our systems and how they operate and where they can be utilized. Just remember, everybody, that the systems that you saw not only can be utilized in whether it's body shop, we do build systems for paint shop and assembly. The one that Paula walked through is this particular system right here, which is performing 3 different functions for an automaker. So once the vehicles do get delivered to the final customer acceptance line, we're not only measuring the flush and gap, we're doing surface inspection and component validation. So what that might mean to you is it got the right trim, door handles, mirrors, antenna, the right wheels, emblems, decals, things of that nature that are on the vehicle. So with that being said, we're going to cover many of the features and the technology behind each one of the features. So I'd like to keep kind of the pace at this point in time and get through just exactly how some of our technology works. So on the technical front, right, each and every part that is determined as what we call a measured point or a measured section is going to be measured by 2 cameras from 2 different angles. All right. And what we're looking to do here is to get the most accurate measurement based upon what the cameras see compared to the 3D CAD models. And we're looking at not only the gap, okay, the gap here, but we're also looking at flushness. Obviously, the idea behind flushness is to have 0 differential here for flushness. As you can see here at this reading here, it was about a plus or minus here about 2 mil on this. So there's quite a change there, but it should be the closer to zero, obviously, the better. We do measure gaps. Typically, they run in the 2 to 4 mil area, and we get as precise as down to 0.2 of a mil if required. This is using stereo vision in order to get this created with high resolution cameras, and Eines does make its own vision cameras and software to help support our systems. So here what we can see is that when these two cameras are looking at it from two different angles, we get two different measurements and outcomes. And what we have to do in our process of correlating our system, while we have fixed cameras and vehicles go through the tunnel, we also produce a handheld flush gap gauge reader, and we do the correlations. We can do it with that or a competitor model. But what we want to make sure is that the flush gap that is being measured with our handheld units are within tolerances also of what our fixed camera is also measuring. And this is how we do our correlation process. And again, some of the tunnels that Polo was so kind to see us in terms of, this is what it looks like when it's just doing flush gap. Okay, we have flat white light that is taking away any of the shadowing, and then you'll see all the number of cameras. How many cameras is very dependent upon the vehicle itself, but it can range from anywhere from 40 to 55 cameras or more, depending upon the number of points being measured along with the size of the actual vehicle. Some of the feedback we get for our metrology is not only whether it's out of conformance, but whether it's in conformance or on the edge and may need to have look by a operator to buy off on it. But as long as it's in the green, we're shipping those particular vehicles. These screens can be all customized in order to not only show the points that are being measured, we're also looking at symmetry and the parallelism. So if we're starting to see where the doors are being fitted and there's starting to be a large gap at the top and narrower at the bottom, we can alert upstream where the doors are being hung as to improve quality. Again, another technical feature that is being performed in our tunnel, not only do we do measurement, I call it measurement and inspection, right? Because the previous technical feature dealt with metrology. This is dealing with error proofing. So it's component check. And we're looking at all the different types of components that are customer facing, that a customer would see that need to match the VIN number for that level of trim package, whether it's your mirrors, door handles, rims, wheels, badge. We can detect and do OCR reading on barcodes if we need to, and also look at the actual placement of the emblems and decaling and lettering to make sure that the labeling is true and square to the fit and location of the vehicle, along with it being the proper naming of for that vehicle. So, you don't want a XLT vehicle built with a XL emblem. So you want to make sure that the two are correct. We're also looking at the proper tires. So how this technology is a comparator style technology, where we are looking at different features, making sure that there's the right amount of bolts and nuts that are on the vehicle, along with the proper rim. And if it's missing any type of component, we're going to identify it. So we take an image of what right looks like, and we lay it over there. So a couple things to keep in mind is, again, while you're seeing maybe a image here that's monochromed, we can do color also. With that being said, we need to now relay that data. If we've found any component that has failed, we will look at misbuilds, and we will also look at missing components. So just because it's a misbuild might be wrong component for that VIN number, a missing component would be, it didn't get a door handle put on it, or it didn't get a mirror put on it, or something was totally missing off of the actual construction of the vehicle. But this feedback provides operators a quick one-over so they can check out the different types of errors that might come up. One of the most interesting ones that we're now dealing with happens to be on these A and B pillar and C pillar with regards to different types of finishes. Now we're starting to see automakers put in gloss and matte and all different styles of finish that we're having to identify that based on the VIN number. And we were just at an OEM 2 weeks ago, and that was one of the items that our system is not even fully functional, but it is doing its model training. And during the model training, it identified one side got a matte finish cover on the B pillar, and the other side got a gloss finish cover on the B pillar. And it got all the way out to the logistics yard before somebody hunted it down and found out, yep, it was improperly built. A couple other things that we're looking at, and we're adding to the tunnel. Not only can we measure and then do the air proofing with the inspection, but we're also looking in, and we provide this as a feature, is scratch and dent. So prior to, and this is really for traceability. So we're looking at the scratch and dent features that might exist on a vehicle before it goes out to the shipping and logistics delivery yards. And we're doing that last image of and detail the last status of that vehicle before it goes out of the factory. So therefore, it has been utilized for warranty claims, along with not only rework before the vehicle goes out, because it's much more cost effective if the rework is done in-house than once it gets all the way out to a customer or a dealer. To the point that, and just how big of a issue and a warranty cost this is to automakers, one individual plant of one of the major OEMs is experienced, now we've cut that down, but experienced nearly a $12 million annual warranty cost just from the dealer network of errors on the vehicle and surface imperfections. So I'll move forward here and show you just exactly what we do. So this is where the AI technology has really been utilized in all of our algorithms. This is a process where we need several different types of samplings where we're developing the images, and we also can simulate images. So we have a collection of real world errors and we have a collection of simulated errors, and we're able to bring them together to help improve the neural model that is important on having the vision system know when it's a defect and when it's not a defect. We stitch these images together to get the super image, so therefore it can be displayed and positioned on the vehicle as to where the error would be. we are classifying several different styles of defects, but scratch and dent in this particular example is being identified to the operators as to whether or not they need to do any work and what type of work they need to do per the different type of classified error. So with that being said, we're really looking to develop the modeling off of set criteria. This criteria is developed in conjunction with our technical team and the OEM's specifications. So let's say it's a scratch and it's over 4 millimeters long, right? We need to make sure that it is identified. We have to set some parameters as to our threshold of what a defect is. Some of the examples here again with what we call the butterfly style images of the vehicle, and then identify which type and style of error it is for identifying and getting, I'm going to call it quick responses from the operators as to where they go. So they're not hunting around the vehicle for the error. They know where exactly to go. We're tracking this. This information also can be in a compatible CSV file and pushed up to the OEM's manufacturing enterprise software. The magic behind some of it, other than the cameras that we produce and the high resolution cameras with our software, but is the use of this zebra lighting, right? Because the zebra lighting is very important in order to identify any lines, I guess you might call them, because we use any of the imperfections in the lighting as an indication of an error on the vehicle. Our vision systems can pick out scratches, but dents tend to be something that we can see through the difference in the zebra lighting. And what we've been able to do in order to make this a reality for many of the OEMs is to develop an all-in-one system. So it takes up a small, as Paula said, 2.7 meters wide, okay, along with 5 meters long. It's a very small piece of real estate, and it's doing 3 different functions. No robotics, so very low cost with maintenance, not having, essentially once it's installed and correlated and working properly, it should be set it and forget it, other than some maintenance maybe weekly to wipe the lenses and make sure there's no contaminant on the lenses of the vehicles. There's no moving parts, so we're able to manage installs very quickly and easily through safety departments. The only challenge you may see when it does get installed, if it's over a certain length, that it will need some sort of sprinkler fire suppression system, which we've been able to work with various OEMs in how to have that system not impact the performance of the flush and gap all-in-one tunnel. And again, this is what it looks like when you're standing in it. Personally, I've been able to be a part of the installations on this. The largest tunnels can take, maybe about 4 days or so. But if we have no production and we have a good crew working in terms of getting at it, we're able to put these up in a very, very quick amount of time. And one of our last technologies, which is really where we began this journey, was in the paint department, right? Because we were able to look at defects that are down to 0.2 millimeters in size. And we want to be able to pull out any of the defects. So here's how this technology works, right? And just to kind of give you a little bit of an idea, I think this might have a video here. So I want to play the video, and you can see maybe I can get it back here for you. You can see just how big a certain type of defect shows up, and why it's imperative to get these defects determined very early on, because it's kind of a thing of compound error with painting, right? If it starts off in the e-coat and then gets through primer and then gets through, top coat, this thing builds and builds and builds, and pretty soon you've got a big error on your hand that you need to either, sand off, and then it can cause a whole new situation of events that has to happen in order to get it. So just kind of look at the video here. You can see as to where we get different pinholes, right, that are crossing our camera lenses. And we know that based upon the position of the vehicle, every one of the vehicles that come to us, we're tracking either through a sensor and or encoder to determine the location of that vehicle at any given point in time. How does this data collection work? Now, this is where we can get up to, on a vehicle going through our paint defect detection system with the high resolution cameras, and we're working at, better than 60 frames a second. We're going to create anywhere between 20 and 40,000 images. That data's got to get collected and stored. Now, we're not going to store it for years and years unless we want to push it to one of the servers that an OEM has, and we're more than glad to do that. But we're going to purge this data after a certain set period of time, which is something that's talked about when we actually scope out the project as how long we should retain these images in the system. We're able to take these various different styles of images that we're identifying, and through AI, we classify the different images as whether it's a bubble or pinhole, or maybe it's dirt, dust, sag, scratch. I know there's like drips, and we call this shrinkage, but there's orange peel also. That is something that is detected. The feedback is super important on the paint defect detection systems, not only as to placement on the vehicle and location of the vehicle, but it needs to be bought off, right? So you got to have a device where we do display these on overhead monitors, but we're very agnostic to any type of either tablet, smartphone that we can put the information on, and an operator can quickly, say, oh, there was a fault on the door. It's up in the, top region. Usually they section out a door by a grid analysis, and we can build that grid analysis into our system also. So if you've already got a grid system for your door, and maybe this is, section, C3 or something, because usually they start with A1 up in the front and they work their way back, and, it'll show exactly the location of where that error is, and if that error can be, sanded or stoned and then bought off. So here's a great example of our tunnels with regards to what you might see in a normal paint shop. Not only would you have one of our systems, which usually there are about 6 cameras in this style of system that is doing the tail lift, either liftgate or tailgate, of the vehicle while it passes by. And this is up where the roof, hood, sides would be inspected when the vehicle comes up. So you can see there was a corner back here with where our system's doing the tailgate inspection, and then as the vehicle comes through on these roller bed conveyors, we're able to do the defect detection of the balance of the vehicle once it enters our system. And remember, this is not stopping at any point in time. None of our systems are stop station. They're all in line while the vehicle is moving. So with that being said, I'd like to turn the webinar back over to Paula, who is with Daniel, to do a technical demo on an actual car inspection and some of the results that you can expect to see from our tunnel. So Paula, take it away.
Good morning or good evening, depending from which part of the world you are watching us, and welcome to the live demo. My name is Daniel Dapena, but they call me Dape, and I am the developers team manager here in Eines, responsible of this system. What is this system? As my colleague already said, this is a tunnel called all-in-one system. Let me turn on the lights and we will go inside to check one by one all the different lights and parts that is composed by. Okay, so please follow me. We have here 3 different tunnels within one. They are working separately, but at the same time. Okay, that means that, for example, if they switch off one of them, the others will still be working. So let's face the first one. The first one is the Surface Damage Inspector, or SD. This SD is working with several cameras and a zebra light. Okay, this zebra light, this black, white reflection in the car is helping us to not only detecting scratches, but also dents. We are composing with thousands of images in every cycle, a super image with the information that is required to have all the detections. Later on, we will show you an image of how this car is going to be inspected. Okay, let's move forward for the next 2 panels of light. These 2 panels of light is for the flash and gap or metrology system. This flash and gap is working with specular light plus stereo vision. With this stereo vision and the 3D of the car, we are measuring the gap and the flash between panels. Let me show you here in the car what is this about. So you can see these 2 panels. We are measuring this gap between 2 panels, and also we are measuring if they are correctly aligned or not. This is always defined by customers. Okay, so later on we will show you also the defects on a screen, how they see it and how they can interpret all the results. And by the end, this last arc is responsible for the spec check. This spec check is not only by this light, it's helped also by the other lights. It's using the same cameras than metrology, and we can add extra cameras if required. Is the responsible to check if the car is completely and correctly assembled. That means the logo is correctly placed. This should be chrome or plastic. This should be chrome or plastic. Do we have this light? Do we have sensors, parking sensors? But not only about presence, we can also check materials, plastic or not, or colors. Is this mirror in the correct color? This is something that is solved by the spec check, by the last part of the tunnel. Okay? The last but not less important. Let me turn off the lights. Sorry. Turn off the lights and let's start the cycle. This will start moving. Okay, now it's moving. Right now, we are grabbing thousands of images from every camera that you can see in the whole space. These images are managed by an encoder. This encoder is giving us the image in the right moment. within 60 seconds, we are grabbing more than 10,000 images per car. That means, for example, if we think about Netflix capabilities, this is like analyzing almost 10, 12 movies in a cycle time. So it's a very, very huge amount of data that we are processing to have all the defects that I have explained before. Okay, the car is moving. Remember, when the car is finished, the car will come back, but in a production line will go forward and the next car will come. Can you please show a little bit? I don't know if we are able to see, but maybe we can see these dents and scratches. Yeah, I'm pretty sure you watch them. Okay, so remember, the car now will stop and will come back, but in production line will come another car. What is the distance between cars? This is a good question. By simulations, we can estimate what is the minimum distance that we need to check every single part of the car that is required. Normally, we are working with 1 meter at least of difference between two cars. So the minimum gap distance, 1 meter. Okay, so let's move to the inspections that we have for this car. Let's start for the metrology, the last one. This is the metrology. This is all what we saw in this car. It's a lot of measures, more than a human can do in a line or a robot. You know, one of the best advantages of this system is that we can measure a lot of points because we are not stopping and we are not going to the car with a robot. We don't have this limit. Okay, we are having stereo points in every place so we can measure, and the information here is as follows. We have the gap and the flash for every place, and we act like a semaphore. If it's green, it's okay. If it's red, it's not okay, and this is a warning that it's under tolerances, but you have to keep an eye. This is configurable completely by the customer, and it's always done by their specification. Okay. Normally, what they do, if they need to repair this, the minus is warning the operator if they have to push or not this piece. And what they do is to use later when they repair, they can validate with our AH2. Can you come with me and you will see? So with this device, imagine that they are working this gap, then they measure with the laser and with this device. This is also from Eines. This is the AH2, which is also used to train the system, the metrology. So let me put it on back on the desk. Sorry for the movements. So let's move forward. This screen. This is the representation of what we are doing with more than 1,000 images for one camera. As you can see, let me take my mouse. We are detecting the dents, several dents in the car. I think you saw on camera this at the end. These are the dents that you saw. But this is not the only camera that we work with. We also are scanning scratches. Remember that these images are later processed by a neural network. This neural network is trained by ourselves, is customized by ourselves, and is right now it's the data set of these dents and scratches is having more than 6,000 instances of this defect. Okay, so it's a very good trained model. It's very, very general, and right now it's detecting the dents and the scratches with a confidence of more than 99%. Actually, you almost cannot see, but this is 99%, and you almost cannot see. Okay, so what else? By the end, the spec check. We have this solution on the screen, which is 3D. But also, and I will go to this device, we have this, the same on a tablet. Okay, now it's refreshing because it was blocked. So, what do we have here? What we have here is the inspections of all the systems that we have. Right now we have, because if not we are going to have several points, we are showing the surface damage. If we click on one of them, let's go to the screen, which is bigger. Here is, you can click a defect, you can give a feedback of every defect. It's telling you that this is a dent by 99% of quality. It's pretty sure that this is a dent, and you can give feedback, claimable. You can save the feedback. So now you have this. You can also check scratches. This is a scratch. So imagine this is not claimable, but you can put not claimable, another feedback, save. And that is how this works. In the tablet we have the same. Another, this is because we are testing in the other place with several things. This is in a scratch, 91% of quality, claimable, save. Now we have. Let me put the component. 1 second. I need to zoom out and select the components. Okay. So now it's everything shown here. Let me zoom and let's see. What can we see? Is the logo placed? No logo. The logo was not attached in this wheel, so they need to check. The parking sensor is placed, that is why it's green. In this case, we are looking for this. You can see, yes. You can see it's on green. Okay. What else? The heat cover, we don't have it. And this is a scratch. Okay, another scratch on plastic, so you can see everything. Why is this very important, this tablet? Because this way you don't depend on a line and on the screens. You can go directly to a box. Imagine that you are working with this car. You can put this car out of production and you can check manually if you want with this tablet. Okay, of course it requires connection because it needs to transfer the data to the tablet, but this is the only requirement that this system has. So now, to finish, I finished completely with the demonstration. Let me tell you the real advantages of this system. I will put here because I think the site is quite pretty from here. So we are living in a very fast world where many operators are working several hours. So what is the real advantage of this? The algorithms are working exactly the same at every time. We don't have dependencies on the zone, despite the operator, for example, that maybe if they see down or up, they are not good enough. But with the system, we can ensure this quality is the same at every place. But also about the metrology, we are able to measure many different places in only 60 seconds. This is a very good point, because no other can. We can do 10 measures but not 14 per site. And by the end, the most important thing is the data. We are grabbing all of this data that we can use later on to do a brief and a very extensive analysis of what are the defects that we are having, not in the car, in the production. We can match this data. Okay, so for me, is everything done? I hope I'm in time. I don't know if I was very long. So we will keep in touch. Thank you for attending, and goodbye. I will.
Thank you very much, Daniel. And I know we're running tight on some time here, so I want to get through some of our last little bit of videos and screens, and then go into a Q&A session, because I know we've got some in the chat that are being asked. So right now, well over 85 of these systems are in place, always improving. The importance of getting that big data right is to make sure that this is a walkthrough. All of the information that you saw that Daniel displayed with regards to scratch and dents and different types of surface defects, you're able to go through and actually pull information on and search it by VIN number and find what that error was. So for the sake of time, I'm going to move this to this screen here, where we're able to actually see where many of our customized screens can differentiate not only the different types of defects, where the defects are located, which models are receiving the most defects, and what stations are indicating the defects are at. And then here in our flush gap system, right, we're looking at not only the number of points. So we have several different systems that are in the working at different OEMs right now, where we're measuring up to 120 points per vehicle. Some of them are up to 210, I think, is the highest that we've gone. But just make sure that you understand that there's a time from when you can do the measurement to the display. And typically I need about 3 meters behind the tunnel in order to display. So about 18 feet, I can get most all of the displayed information, in case there's a fitter that's prepared for that. We do develop heat maps that also associate with the vehicle when we analyze it. So just as Daniel was showing some of the errors in like the doors, we can develop heat maps that associate with it. And through our systems with regards to being agnostic, we're able to connect to most any OEM MES system, along with pushing it to the cloud if needed for storage and offering those cloud services. And last but not least, in a smart manufacturing world, we provide the vision systems for those worlds. So with that being said, I'll just do a quick intro on Konica Minolta, just to wrap things up. As you know, we're a company that's headquartered here in Spain. Eines is. Konica Minolta is global, been around more than 150 years. We have several sister companies that are in the sensing and vision, and we collaborate on a lot of different types of collaborative programming. So we're getting the best of both worlds out of the 5 different entities. to, we do break up our technology into these different 4 pillars, whether it's quality inspection with paint, metrology for measurement, airproofing for spec check or identification of part present, and then 3D robot guidance for maybe sealer check or windshield install and things of that nature. And last but not least, I'm going to give it over to Patricia for a poll question. So she'd like to provide you with one last poll question here.
Exactly, Mike. So thank you for your nice explanation, and also thanks to Paula and Daniel for this nice tunnel demonstration too. Okay, so first, before going to this Q&A session, we have a lot of questions in the queue. Let's see if you would like to receive further information. So you can select more than one option, and these results will be not shared with you. Okay, so you can select your options. Is totally anonymous. Okay, so Mike, if you agree, I can read out loud to you the questions.
Sure.
So let me start with the first one.
We'll leave the poll open for a bit and then go ahead and read to me the question.
Exactly. Yeah, I will maintain this poll open. And let's start with the first question from our audience. Ernest is asking, can your system take vehicle images after customer acceptance line so OEM knows how the vehicle left the manufacturing facility?
Can you repeat that one more time? What is it now?
Yes, of course. Can your system take vehicle images after customer acceptance line so OEM knows how the vehicle left the manufacturing facility?
Yes. Yep. We can do a photo finish of the vehicle. Yes.
Okay, so thank you, Mike, for your answer. So Zach is asking, does the system give you out a summary report for each vehicle, like a cell report that summarizes the top issues, FTT, etc.?
Yeah, we can customize it to provide it per VIN number or per group of types of vehicles, per model. It's all dependent upon how we want to display that information, but sure, we can have a summary for each VIN model or each style.
Perfect. Thank you, Mike. We have another question from Zach. So how does the system respond to water and mud, like in the case of a vehicle that was driving from outside in the rain, for example?
Mm-hmm. Yeah, it can be a challenge for doing the measurement. Now we've worked through being able to provide the measuring on vehicles, but we can't guarantee exactly every single point will be measured if the water droplets are right at the location of the measured position. Now for airproofing, it's a little bit more forgiving and we're able to do that, but for measuring, it really should possibly run through a dryer first.
Okay, perfect, Mike. So we have another question from Sarnesa. So once the image is taken, where it is stored and how will we as the OEM get access to it?
Yeah, so currently what we do is we store it on our local drives, and we've got, depending upon how long you want to store that image, we will build the system to accommodate that. If you want the images pushed to your server, we can do that, and you can store them for as long as you would like, and the images. But normally we store the image itself, and there's 2 components. There's the image, and then there's the text data. The text data is stored for 24 months. The image itself is purged after 2 days for the measurement side of things. For the airproofing, we can store that longer, and some OEMs have us storing that image information up to 1 year, and we can customize the system to accommodate that.
Okay, thank you, Mike. So let's go ahead with the last question. How long is the installation time?
Okay, so the installation time can vary based upon what we're putting in. Obviously, for the flush gap system, we need like 3 days. If we can have solid 3 days no production, we're usually able to install because our system is shipped to the place of destination in a modular type of shipment, and it's assembled quite quickly. If it's a more elaborate system with many features and camera and arrays of light, then we would like to have at least 4 days of no production and built. If it happens to be a situation where we can't get 4 days back to back without production, then we have done it over 2 weekends.
Sounds good. So thank you very much, Mike. I think we can close the webinar.
Sure. Yeah.
There is no more questions. So I would like to say that when you close this event, you will have a survey. We would like to improve, and we would like to know your feedback about that. Of course, we will send you the information you request. And thank you again for your attendance. Mike, you will say something to our audience?
Yeah, I really appreciate everybody taking the time to listen to our seminar, and both Paula and Daniel for doing their excellent job in walking through the demo, and yourself, Patricia, for being a host of this. And if there's additional questions later on, you see our names and emails, you may reach out to us, and we'd be more than glad to answer any additional questions.
Perfect. So thank you, and see you.
Thank you, and enjoy the day. Yep.
you